What we will do now is move on to the last section of Chapter 5, Section 5.3. All students will be able to construct and run a simulation. One of the many types of questions we'd like to answer in statistics is being able to answer questions that involve chance. For example, let's say that we have a family that's going to have 4 children, and we want to know what is the likelihood of them having at least one girl in their first 4 children that are born. Well, we have different ways in which we could try to answer this question. One way is by doing an experiment. Well, that might not be necessarily appropriate in this case. A second way is by developing a probability model. We're going to talk about that in the next chapter, how we can use probability and the rules of probability to help us answer a question like this. The third way we're going to talk about right now is learning to construct and run a simulation. So let's give a definition of a simulation. What we're going to say is that the imitation of chance behavior based on a model that accurately reflects the experiment under consideration is called a simulation. So what I'm going to do is use this example, which I got from examples 5.20 and 5.21 in your book, to illustrate the steps that I need to see in your work for you showing how to run a simulation. So I'm going through examples 5.20 and 5.21 here. And these are going to be the steps for running a simulation. The first thing you need to do is to state the problem or describe the experiment. For our particular problem, our problem is we want to know what is the likelihood of having at least one girl in their first 4 children. Step 2, state the assumptions. Whenever we run simulations, there are certain assumptions that we need to make. For example, one of our assumptions we're going to make in this problem is that a boy or a girl is equally likely for any child. Whether you have a boy or a girl, they are equally likely. You could think of it as them having a 50% probability of occurring for each child. And the second assumption we're going to make is that each child is, well, let's phrase it this way, each child's gender is independent of that of any other child. When I say that the gender is independent, that means that the gender of any other child does not influence or change the gender of any other child. Step 3, assign digits to represent outcomes. What we're going to do for this particular example is I'm going to use random digits to run this simulation. Basically, what we're going to do is we're going to simulate this problem by saying, let's let the digits 1 through 5 represent getting a boy, and the digits 6 through 0 represent getting a girl. Now, that's not the only way in which you could represent your outcomes. You might say, let the even digits represent a boy and the odd digits represent the girl. You might flip coin. You might say that if you flip a coin, heads represents getting a boy and tails represents getting a girl. But let's stick with this setup for now. So always make sure that you state what your assignment of your digits to your outcomes is going to be. Step 4. Simulate many repetitions.
Greg Preston, please report to the guidance office. Greg Preston, report to the guidance office, please.
Okay, so to simulate many repetitions, what we're going to do is we're going to pick a certain row on the random number table to start. For teaching convenience here, I'm going to start with row 101 on your random number table. And I'm going to take the first 4 digits in that random number table, one for each child. The first 4 digits are 1922. That represents one run of my simulation. Since we're interested in knowing how many girls there were in that family, I'm going to keep a count of how many girls are in that family of 4. We said that the digits 6, 7, 8, 9, 0 represented getting a girl, so I count that there was one girl in this run of the simulation. I'm going to take a look at the next 4 digits now. 3950. 3950. In this case, there were 2 girls. And you can proceed on and on. After 3950, I get 3405. 3405 represents, again, getting one girl. And one of the advantages to these videos is I can just skip ahead and say, now let's run this 20 times. And there's a run of doing this 20 times. Each time I recorded the 4 digits and counted how many 6, 7s, 8s, 9s, or 0s there were for each one. So after running this simulation for 20 times, I'm going to count how many of our outcomes had at least one girl. I count 18 out of the 20 runs had at least one girl. So my final step, step 5, is to state your conclusions. My conclusions for this particular problem would be, I estimate, and that's key, this is an estimate, not an exact answer. I estimate the likelihood or the probability of getting at least one girl in a family of 4 children to be about 18 out of 20, or 95%. And that's it. That's what I want to see for the steps. Please make sure everything that I wrote in blue here, that's what I'm looking for your work. I want you to state the problem or describe your experiment, state the assumptions, and usually our assumptions are equally likely outcomes and outcomes that are independent of each other. Just describe it in the context of the problem. Make sure you state your assignment of your digits. Simulate your repetitions. For something simple like this, it was easy enough for me to actually write out each outcome. It might be a little bit more complicated for a more complicated problem, in which case you don't have to write out the digits every time, but you're going to want to keep some type of running tally that I can follow along with. And then finally, state your conclusions. Okay? Any questions, please make sure that you let me know. Okay? Thank you.